Hi everybody, in this video we are looking at similar right triangles. So let's start with defining similar triangles. Triangles with corresponding angles congruent and their corresponding sides proportional in length. So those would be similar triangles. So inscribed similar triangle theorem states if an altitude is drawn from the right angle of any right triangle, then the two smaller triangles formed are similar to the original triangle. And all three triangles are similar to each other. Okay, so let's take a look at example 1. Write the similarity statement for the triangles below. So you can see the altitude going from the right angle to the hypotenuse of the big triangle. The gray and the light green triangles are the smaller similar triangles inside. So you can see we get three 30, 60, 90 triangles here. So triangle, let's do the big one first. Triangle EIR, that's the big triangle, is going to be similar to, let's find the 30-degree first, RIT, that's the small triangle, it just made blue for a second, is going to be similar to this gray triangle, ERT. So remember that the angles of similar triangles are congruent and all the corresponding sides are similar. So in example 2, find the value of x, which is the altitude of the large triangle. I'm going to redraw the triangles. The large one's going to be gray, the medium's going to be green, and the small one orange. Okay, so label all the vertices and all the sides that we know. Take a minute and do this. Once you have this done, we're going to write the similarity statement above. Okay, so I can write triangle EDG, and the large one, is similar to triangle DFG on the medium, is similar to triangle EFD on the small. So now what we're going to do is set up a proportion so we can solve for x. So I can say x, which is FD, to 6, which is ED. So I'm saying medium side to the hypotenuse equals 8 to 10 on the large triangle. So medium side to hypotenuse equals medium side to hypotenuse. Now I can multiply both sides by 6 and I get 48 over 10, x equals 4.8. Okay, so we use the proportional statement here between the small and the large using the medium side to the hypotenuse. Okay, so find the value of x, then find y, for example 3. I've got the large triangle, the smaller salmon-colored triangle, and then the medium blue triangle. So I can say the shorter leg in the small triangle to the shorter leg in the medium triangle, which is going to be x, equals the hypotenuse in triangle SVT, the smaller triangle, to the hypotenuse of the larger triangle, which is 20. So I get 4 over x equals x over 20. I can cross multiply and solve for x. So x is going to be the square root of 4 times 20, which is 4 times 4 times 5. And the square root of 4 times 4 would be 16, which is 4. My answer is 4 root 5 for x. Okay, now we need to find y. So we know in the large triangle here that the short leg is 4 root 5, that's x, and we know the hypotenuse is 20. We could use the Pythagorean theorem to find the other leg. So I'm going to substitute 4 root 5 in for A and 20 in for C. Now 4 root 5 squared is the same as saying 4 root 5 times 4 root 5, which 4 times 4 is 16, and root 5 times root 5 is 5. 20 squared is 400. Solve for y by subtracting 80 and then taking the square root of 320, which I can factor this into 16 times 4 times 5. Now 16 and 4 are perfect squares, so the square root of 16 is 4, and the square root of 4 is 2, so it would be 8 root 5 would be my final answer. Okay, what is the geometric mean? We've kind of been using it here without knowing it. The geometric mean of two positive numbers, a and b, is the number x such that a over x equals x over b, so that x squared equals a times b, or x equals the square root of ab. So there's three different formulas. They all mean the same thing. So let's find the geometric mean of 24 and 36. So we say 24 over x equals x over 36. We can cross multiply and then take the square root of x. And I want to write this in simplified radical form. So I'm finding my factors here that are perfect squares. 36 and 4 are perfect squares, so when we take the square root of those, we get 6 and 2. Root 6 stays under the radical, so I get 12 root 6. So let's find the geometric mean of 18 and 54. So I'm going to use the right equation here, already solved for x. X equals square root of ab. So I'm just going to substitute 18 for a and 54 for b. And I know some factors here that are perfect squares. 9 times 2 is 18, and 9 times 6 is 54. So 9 times 2 times 9 times 2 times 3. The 9s and the 2s are pairs, so they can come out of the square root. And I'll just rearrange the order here. So you can see 9 times 9 is 81. The square root of 81 is 9. 2 times 2 is 4. The square root of 4 is 2. So my final answer is 18 root 3. Okay, so the geometric mean similar triangle theorem number 1 and number 2 are as follows. In a right triangle, the altitude drawn from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of the altitude is the geometric mean of the two segments. Okay, so AC in this drawing would be the altitude, and BC and DC are the two segments that we're referring to. So I can say that BC to AC equals AC to DC. Now AC in this case is the geometric mean, and BC and DC would be A and B from the equation. So the theorem number 2 states, in a right triangle, the altitude drawn from the right angle to the hypotenuse divides the hypotenuse into two segments. The length of each leg of the right triangle is the geometric mean of the lengths of the hypotenuse and the segments of the hypotenuse that is adjacent to the leg. Okay, so this sounds really complicated. So we can say that the small leg to the hypotenuse equals the small leg to the hypotenuse in this case. And then also the medium leg to the hypotenuse equals the medium leg of the hypotenuse of the respective triangles. So although this theorem might be useful for some, you just might want to redraw the triangles and make your proportions to solve using similar triangles. It's up to you. Okay, let's take a look at applying the first one in example 7. So x in this case is the altitude, and 9 and 27 are the segments of the hypotenuse. So we can use the geometric mean to solve for x in this case, but it's still the shortest leg of the smallest triangle to the shortest leg of the middle triangle equals the longer leg of the smallest triangle over the longer leg of the middle triangle. We're still using a proportion in this case, but it just so happens to be the geometric mean. Okay, so we can say 9 over x, which is going to be the altitude, which is the geometric mean here, equals the longer leg of the smallest side, x, over the longer leg of the middle side, 27. So the two numbers are 9 and 27, and x is the geometric mean. So we can cross multiply. I get x squared equals 9 times 27. Don't multiply these numbers because we want to try to simplify it anyway, and that just makes more work if we multiply and then factor them again. I know 9's a perfect square. 27 has a factor in it that's a perfect square too. It's 9. 9 times 3 is 27. So the square root of 9 is 3. The square root of the other 9 is 3. That can come out as 9. 3 times 3 is 9. And then root 3 stays under the radical. So that's x. It's 9 root 3. Okay, example 8. Find the value of x and y. So I'm putting a z here. We could find the altitude and then use the Pythagorean theorem to find x and y. Or we could set up a proportion to solve using the geometric mean theorem number 2. And since this one is the difficult one, or one that we're not familiar with, let's try that one first. So I can say the long leg of the medium triangle, which would be 20, divided by the hypotenuse of the medium triangle, which would be x, equals the long leg of the large triangle, which would be x, over the hypotenuse of the large triangle, which would be 15 plus 20, or 35. So the medium triangle is this pink triangle here. So the long leg is 20, and the hypotenuse is x. And the large triangle is the whole thing, both those smaller triangles together. The large leg would be x, and the hypotenuse would be 35. So now I can cross multiply and solve for x. 20 times 35 on the left, x squared on the right. I'm going to take the square root of this. Again, I don't want to multiply these numbers 20 and 35 because I'm going to end up factoring them anyway. So 20 factors into 4 and 5, and 35 factors into 5 and 7. So do you see the two 5s there? That means that we have a perfect square in there. And the 4 is also a perfect square. So I can take the square root of 4 and the square root of 25 out, and I get 10 root 7 for my answer for x. Now I could use the Pythagorean theorem to find y because I've got the leg and the hypotenuse in the large triangle. But I'm going to use the geometric theorem number 2 to find y, just because it's something that we're not used to doing. So I can take the short leg of the small triangle, which is 15, divided by the hypotenuse of the small triangle, which is y, and that will equal the short leg of the large triangle, which is also y, over the hypotenuse of the large triangle, which is 35. So I get 15 over y equals y over 35. Again, this is the geometric mean, right? Y would be the geometric mean, and 15 and 35 are the two numbers. So cross multiply, take the square root, simplify the radical. You could factor these here and see that I get two 5s. So 5 times 5 is 25. Seem to be taking a little break here. Let's get it back to the problem. There we go. So The 5 will come out and the 3 and 7 will stay under the radical. So I'm going to get 5 root 21 as my final answer. And that's it. So review this section if you need to. Remember, you can always redraw the triangles to set up a proportion. Try the practice set. Mr. Mac out.